Hello students. In the previous class we have seen what is a hypothesis, what are the different types of errors, what is a critical region and what is a procedure for testing of hypothesis. Now in this class we will discuss about the last sample test here. So as we know that this unit testing of hypothesis is carried out into large samples and small samples. So what is a large sample? When the sample size drawn from the population is definitely greater than 30, then it is a large sample here. Now again, these large samples are classified into two types as the quantitative data and qualitative data here. So quantitative data means the data which can be measured in any of the physical units, and qualitative data means the data which cannot be measured in any of the physical units. Now we have to carry the testing of hypothesis for both the quantitative and qualitative data here. So the large sample means it can be 31, 100, 500, 1000, 10,000, 20,000 and even 1 lakh also. Now in this class we will cover the large sample test for single mean, difference of means, single proportion and difference of proportions. So as we know that the first step in the procedure for testing of hypothesis is framing the null and alternative hypothesis here. So when we are considering only a single sample from a population, then here the test for the single mean regarding the hypothesis is given as mu equal to mu naught, where mu is the population mean and mu naught is a specific constant of the population here. Then if we consider the two different samples of size n1, n2, definitely n1 greater than 30 and n2 greater than 30, then to test whether the two population means are equal or not, the h naught is given by mu1 equal to mu2 here. And if we talk about the qualitative data, means the data which can't be measured in any of the physical units, right? And if we consider a single sample drawn from a population, definitely the size greater than 30, then to test whether the population proportion is equal to a specific constant, the null hypothesis for single proportion is given as P equal to P naught, where capital P represents the population proportion here. And if we consider the two different samples of size n1 and n2, where n1 is greater than 30 and n2 is also greater than 30, then to test the equality between the two population proportions, the null hypothesis is given as capital P1 equal to capital P2. So here I am stressing capital P1 because we have a sample proportion which is denoted by small p here. So in this way we have to frame the null hypothesis. But when coming to the alternative hypothesis here, right? So we know that the alternative hypothesis is classified into one-tiled and two-tiled here. So when we are considering that there is no significant difference, right? There are no comparable words, then H1 is given as for the single mean, mu is not equal to mu naught. But if we observe any comparable words like greater than, less than, superior, inferior, then definitely it is left-tiled or right-tiled. When mu less than mu naught, H1, then it is called the left-tiled alternative hypothesis, and mu is greater than mu naught, then it is called the right-tiled alternative hypothesis. Then, if we consider the two different samples of size n1 and n2, and we want to test between the difference of means here, then there are no comparable words, then in that case here H1 is given as mu1 not equal to mu2. And if there are comparable words, depending on the question, it can be a left-tiled or it can be a right-tiled. That is mu1 less than mu2 is left-tiled and mu1 greater than mu2 is here right-tiled. But when we talk about the qualitative data, that means the single proportion, when we are considering only one sample from the population, then obviously here there are no comparable words, means our H1 is two-tiled, P not equal to P naught. But when there are comparable words regarding the population proportion, then P less than P naught, that is left-tiled, and P greater than P naught, that is right-tiled here. And if we consider the two different samples of size n1 and n2, and when we are talking about the proportions here, then the alternative hypothesis is P1 not equal to capital P2, provided here there are no comparable words. But if there are comparable words in the question, then P1 less than P2, that means the left-tiled, and P1 greater than P2 is the right-tiled here. So in this way we have to frame the alternative hypothesis based on the given data in the question. Then the next part is here we have to identify the suitable test statistic. So for the single mean here, right, the test statistic is given by z equal to x bar minus mu by sigma by root n. So all these last samples are based on the normal distribution, provided the mean is equal to 0 and the variance is equal to 1, right? So all these last samples are completely based on normal distribution with mean 0 and variance 1, that is the standard normal variate we can say. Now we know that the standard error for single mean is sigma by root n. So that's why it is z equal to x bar minus mu by sigma by root n, where x bar is the sample mean, mu is the population mean and sigma is the population standard deviation. But when we consider the two different samples of size n1, n2 and when we want to test whether the two sample means are equal or not, then the test statistic is given as z equal to x1 bar minus x2 bar by square root of sigma 1 square by n1 plus sigma 2 square by n2 here. So here we have two cases. The first case is here x1 bar minus x2 bar by square root of sigma 1 square by n1 plus sigma 2 square by n2, provided the two populations has different variances. But if the two populations has same variance, that means common variance, then x1 bar minus x2 bar by sigma into square root of 1 by n1 plus 1 by n2. Either you can write the sigma inside the square root or outside the square root. But if we are writing inside the square root here, then it is square root of sigma square bracket of 1 by n1 plus 1 by n2. So that's about the means here. But when coming to the qualitative test here, when we are considering a single sample from the population and we are testing the hypothesis of proportion, then for the single test statistic, it is given by here z equal to small p minus capital P by square root of capital PQ by n here. So small p represents the sample proportion and capital P represents the population proportion here. Right? Remember, always the sample proportion and the population proportion should represent the same characteristic here. If we are discussing about the proportion of intelligent students, that means capital P represents the proportion of intelligent students in the population, then the sample proportion small p should also represent the proportion of intelligent students only. It is not like that the capital P is talking about the intelligent students and small p is talking about the average students here. So always the sample proportion and the population proportion should represent the same attribute. Then if we consider the two different samples of size n1 and n2 and we want to compare the two population proportions here, then the test statistic is given as small p1 minus small p2 by square root of capital PQ into 1 by n1 plus 1 by n2. Now here in the difference of proportions, we have to estimate the capital P by using the formula n1 p1 plus n2 p2 by n1 plus n2 here. Okay, so that is about the test statistic. Now after obtaining the test statistic here, we have to just identify the level of significance, right? So the level of significance is nothing but here it is based on the alternative hypothesis, right? So if the alternative hypothesis is two-tiled and the alternative hypothesis is one-tiled, so we have different values for that. We know that the probability of type 1 error is level of significance. So generally by default we consider the level of significance as 5%. If particularly they have mentioned 1% means we have to take 1%, and if nothing is mentioned in the question regarding the level of significance, then by default we have to take 5%. So for 5% one-tiled, the tabulated value is 1.645, and if it is two-tiled, that is not equal to H1, then it is 1.96. Now coming to 1% one-tiled means it can be either less than or greater than right-tiled or left-tiled. The tabulated value is 2.33, and for 1% level of significance two-tiled, that is not equal to, it is 2.58. Now after obtaining the level of significance here, right, and just substituting the data in the test statistic, we have to compare the calculated value and the tabulated value here. So sometimes the calculated value can be negative also. So whenever it is negative, we have to consider the modulus of that. So if zcal or modulus of z calculated value is less than or exactly equal to tabulated value, then our null hypothesis H0 is accepted at a given level of significance, right? But if the z calculated value or modulus of z calculated value is greater than z tabulated value at a given level of significance, then we have to reject our null hypothesis. So here the conclusion is based on the null hypothesis, but whereas the tabulated value is based on the alternative hypothesis here. So in this way we have to test the hypothesis. So we will continue the problems on last sample test. Okay, now just now we have seen the different test statistic for last samples of single mean, difference of means, single proportion and difference of proportions. Now let us see the problems on last sample test for single mean. When we move on to the question, an ambulance service claims that it takes on the average less than 10 minutes to reach its destination in emergency calls. A sample of 36 calls has a mean of 11 minutes and a variance of 16 minutes. Test the claim at 0.05 level of significance. Now, whenever you read the question, first you identify the sample size here. So, a sample of 36 calls means the sample size is here 36, has a mean of 11 minutes and the variance of 16 minutes. So follow the sample size, whatever the mean is given, that represents the sample mean x bar. So we have to test the claim at 0.05 level of significance. What is the claim we have to test here? An ambulance service claims that it takes on the average less than 10 minutes to reach its destination. So if you move on to the solution here, the null hypothesis H0 is given as here mu equal to 10 minutes. And against here H1. So it is given that it takes on the average less than 10 minutes. So a comparable word is there. That means our alternative hypothesis will be one time. So mu less than 10 minutes. Okay. Now under the null hypothesis, under the assumption of null hypothesis, the test statistic is given by so Z equal to x bar minus mu by sigma by root n. So this follows a normal distribution with mean 0 and variance 1 here. Now if you write the given data, so what is the sample size? So to test the claim they have taken a sample of 36 calls. So n equal to 36 and x bar is found to be those 36 calls has a mean of 11 minutes with a variance of 16 minutes. That means sigma square is given as 16 minutes, which implies sigma equal to square root of 16, that means 4 minutes here. Now we know that the population mean is 10 minutes. Now substitute in the Z statistic. So Z equal to x bar minus mu by sigma by root n. So that means here 11 minus 10 by sigma is here 4 by square root of 36. So which is nothing but here 11 minus 10 is 1 and square root of 36 is 6. So 4 by 6 can be simplified as 2 by 3. So 1 by 2 by 3 can be written as here 3 by 2. So that means here Z calculated value is 1.5. 3 by 2 means it is 1.5. Now we have to obtain the tabulated value of Z at 5% level of significance. So at 0.05 we have to test. So Z tabulated at 5% LOS means level of significance for here. What about the alternative hypothesis? Here it is less than, that means one child. So for one child is, what is the tabulated value? It is nothing but 1.645. So if you see the conclusion here, Z-cal is 1.5 and Z-tab is here 1.645. So that means here Z-cal is than Z-tab. So therefore H0 is accepted. So H0 is accepted means what is our conclusion here? The ambulance service takes 10 minutes to reach its destination here. So that is the claim here. So we are rejecting H1. That means an ambulance service on the average takes less than 10 minutes. We are rejecting that. So our conclusion is here, on the average an ambulance service takes 10 minutes to reach its destination. So in this way, first we have to frame the H0, H1. Then based on the given data, here we have to identify the test statistic, then write down the given data, substitute in the Z formula and obtain the calculated value. Now you have to obtain the tabulated value at a given level of significance for the corresponding alternative hypothesis. So if Z can tag here, H0 is accepted. That means here mu equal to 10 minutes. So this is the conclusion for the problem. Okay. So always followed by the sample size, whatever the mean is given, that represents the sample mean. So don't get confused about the population mean, mu and sample mean x bar. So in this way we have to solve the last sample test for single mean. Now let us see the one more problem on test for single mean. The mean lifetime of 100 light tubes produced by a company is found to be 1560 hours with a population standard deviation of 90 hours. Test the hypothesis for alpha equal to 0.05 that the mean lifetime of the tubes produced by the company is 1580 hours. Right? So here directly they have mentioned the population standard deviation sigma value and they are talking about the mean. So here the question is regarding test for mean and we have only one sample size, that is 100. So it is the test for single mean. How to identify whether the problem is single mean or difference of means. So here the data is measured in terms of hours. Right? So if you move on to the solution here, our null hypothesis is what we have to test is the mean lifetime of the tubes produced by the company is 1580 hours. So that means H0 mu equal to 1580 hours. Then against the alternative hypothesis, here in the question we have not observed any comparable words. So our alternative hypothesis will be mu not equal to 1580 hours. Then under H0, the test statistic is given as Z equal to x bar minus mu by sigma by root n follows a normal distribution with mean 0 and variance 1. Now if you write the given data here, the sample size is 100. So n equal to 100. So the 100 tube lights has the mean of 1560 hours. That means x bar is 1560 with a population standard deviation of 90 hours. So here the sigma value is given to you directly and the mu value of course you have to test is 1580. Now substitute in the Z formula. So Z equal to x bar 1560 minus 1580 by sigma is 90 by square root of the sample size is here 100. So this is minus 20 by 90 by square root of 100 means 10. So 90 by 10 that means 9. So what is the Z cal value here? Minus 20 by 9. So 20 by 9 means 2.2222. Okay. So this is Z cal is negative. So whenever the Z calculated value is negative, we can consider the modulus of that. So modulus of minus 2.2222 is 2.2222. Now we have to consider the tabulated value of Z at alpha equal to 0.05 it is given. That means at 5% level of significance, LOS means level of significance for the corresponding alternative. What is the alternative here? Not equal to. That means for 2 tile. So for 2 tile here, the value is 1.96. So Z tab is 1.96 and mod Z cal is 2.2222. That means mod Z cal is greater than Z tabulated value. Therefore, H0 is rejected. H0 is rejected means we are accepting H1. That means here the mean lifetime of the tubes produced by the company is not equal to 1580 hours. So that means that finally the conclusion is mu is not equal to 1580 hours. Right? So whenever the calculated value is greater than the tabulated value, we have to reject the null hypothesis. I hope you understand this problem. Now let us see the last problem in large sample test for single mean. So in a random sample of 60 workers, 60 workers, the average time taken by them to get to work is 33.8 minutes with a standard deviation of 6.1 minutes. Then can we result the null hypothesis mu equal to 32.6 minutes in favor of the alternative hypothesis mu greater than 32.6 and alpha equal to 0.01 level of significance. Now in this question here, regarding the alternative hypothesis, directly it is mentioned in the question, that is mu greater than 32.6. Now, if you frame the hypothesis here, H naught, of course that is also given in the problem directly, that is mu equal to 32.6 minutes against H1 mu greater than 32.6 minutes. Then under H0, so we have to test that mu equal to 32.6 minutes means it is a test for single mean. So Z equal to x bar minus mu by sigma by root n follows a normal distribution with mean 0 and variance 1. Now the sample size is here n equal to 60 workers, right? With average time taken by them to get to work is 33.8. So always followed by sample size, the sample mean will be given. That is x bar is 33.8 with a standard deviation of, that is sigma is given as 6.1 minutes and the population mean mu is of course 32.6. Now if we substitute in the z value here, so z equal to 33.8 minus mu value 32.6 by the standard deviation is 6.1 by square root of the sample size, that is the sample size is 60. Now if we simplify the numerator here, so 33.8 minus 32.6 is 1.2, right? And here it is denominator 6.1 by square root of 60. So square root of 60 is here 7.746. Now if you simplify this here, 7.746, that is 6.1 by 7.746, it is 0.7875. 0.7875. So numerator is 1.2. So finally here the Z calculated value will be 1.2 divided by 0.7875. It is 1.5238. So here our calculated value is positive only. Now we have to obtain the tabulated value of Z at, here the level of significance is given as 0.01. So at 1% level of significance for the corresponding alternative, that means here it is given as greater than, so for one time. So 1% one time, the tabulated value is 2.33. Okay, so Z-cal is 1.5238 and Z-tab is 2.33. So that means here Z-cal is less than Z-tab. So therefore H0 is accepted. H0 is accepted means here the average time taken by the workers to get to work is 32.6 minutes. That is mu equal to 32.6 minutes. Okay, so we have seen the three problems in this. So in the first problem we have seen a comparable word less than. Second problem we have no comparable words in the question. But in the third question directly they have mentioned the comparison between the H0 and H1 here. Okay, so here the level of significance is 0.01. For one time it is 2.33. So Z-cal is 1.5238 and Z-tab is 2.33. So Z calculated value is less than tabulated value. So H0 is accepted. So the final conclusion is here mu equal to 32.6 minutes. So in this way we have to solve the test of single mean here for large samples. I hope you understand this problem.